there are very, very few places where life as we know it can exist.
Hmm.
The Earth is one of them. And we need to do everything we can to protect, preserve it, keep it as a place for life. But we also need to be thinking about how we can take life beyond the Earth. And as I look at the moon and the asteroids, they are dead worlds. They
Yes.
will always be dead worlds. Life will not exist there unless we take it there.
Hmm.
And so I think life is inherently good, and it's a moral thing to try to preserve life all the way from the bumblebee and the hummingbird up to humans.
Hmm.
And we ought to be expanding to take life beyond Earth and into the universe because it's a good thing to bring life where there is no life.
Hello, and welcome back to another episode of David Talks With. I'm David John, your host. Today, I'm thrilled to be sitting down with someone who seamlessly blends the worlds of science and storytelling, Mr. Les Johnson. By day, Les delves into the mysteries of the universe as a physicist at NASA's Marshall Space Flight Center, pioneering frontier space propulsion technologies. But when the sun sets, he transforms into a renowned science fiction and popular science author. With several books under his belt and accolades like the Canopus Award, Les has made a significant mark in the literary world. I have personally been captivated by many of his books, like this insightful book on graphene I'm holding. His works aren't just entertaining, they're deeply informed by his groundbreaking research. And through his fiction, Les champions ambitious real-world space missions. And it's mostly in his capacity as a writer that we're speaking to. It's an honor to have you on the show, Mr. Johnson.
Thanks for having me. I appreciated your invitation. I've been looking forward to it.
Great. So let's start with your day job at NASA. So you're the space propulsion technologist and mission principal investigator at NASA. What does that role entail?
Sure, sure. Well, first thing I have to do is I have to let everybody know that I have to kind of keep a life in two worlds right now. I keep one side of me is the NASA guy working on space missions. The other side is the science fiction writer. And although they inform each other, my employer at NASA likes to keep me, keep those pretty separate. And so I'm speaking to you today as a science fiction writer and a science writer, but I can talk about my NASA job.
Hmm.
And at NASA, I have been truly blessed. I've been there for a while. You can tell I'm follically challenged. Um, and I work on mostly advanced space systems and propulsion technologies. And I've been very fortunate to have some experiments fly in space, a couple of missions launched, most recently a small payload that launched on Artemis 1 last November. And it's been a real pleasure to see the stuff that was science fiction of my youth becoming reality today and actually be able to touch some of that. So it's pretty exciting.
Yeah, that's incredible. It looks like, well, the space race is back again. Like a week ago, we know that India has just launched their space carrier to the backside of the moon. And it looks like some other countries are on the move as well, like China. They plan to launch their launch astronauts to space by 2030. So, how is NASA involved in the new generation of the space race?
Well, first off, kudos to the Indians for successfully landing on the moon. Very few countries have done that. And I was reading an article just the other day and about the project and what all their ambitious plans are, and I think it's awesome. And as far as what the Chinese are doing, they've been sending people to LEO, low Earth orbit, for a while, and they're talking about going to the moon. And as long as
Yeah.
we're all going there peacefully, I think it's a good
Hmm.
thing. Now, NASA's involvement in this new space race is kind of interesting.
Hmm.
And this is all public, knowledge. It's really becoming a public-private partnership. I know that sounds kind of hard to
Yeah.
say
Hmm.
on microphones because so many P's and it tends to blur out. But
Yeah.
the thing is, NASA is actually partnering with some of these entrepreneurial space companies now, as opposed to just buying services.
Hmm.
SpaceX, Blue Origin, some of the traditional aerospace companies like Lockheed Martin, Boeing, and others. We're
Hmm.
really the agency's forming some interesting partnerships to make a return to the moon possible and looking at what comes next. So I'm excited about it. I look at it as kind of an echo space race. These are the people who are doing this are people of roughly my generation, a little younger maybe, who grew up thinking we were going to have 2001 space Odyssey be real in 2001,
Hmm.
that we would have moon bases in Mars, and as they got older and made billions, they got frustrated with the pace of exploration and decided to jumpstart it by finding ways to make it more affordable, and they've succeeded. And I think it's awesome.
Yeah. I'm also very intrigued by the private corporations that are becoming more and more involved in the space industry, especially SpaceX. I mean, I'm an Elon fan personally, but I also think that the technologies that they're developing are quite interesting and quite unique. They cut in from a different angle.
Well, what I've been impressed by is how much they've changed the cost model and how much more
Hmm.
affordable space launch is. For a long time, the single most costly part of any mission was getting it off the ground and into space.
Yeah.
And the cost model and the changes in the cost of how many dollars per pound to get a payload to space has come down dramatically. And what that
Hmm.
does is it decreases the cost of a mission, which allows space agencies and private companies to do more missions for the dollar. And it's no longer necessarily the single largest expense, which is awesome. Maybe now we can put more
Yeah,
emphasis on the payloads and what we're doing in space.
exactly. So, well, as we were talking about inspiration and how your generation is back echoing into the space industry, I'd also like to know what inspired you personally to delve into this the field of space propulsion. Was it Star Trek and the space race, or?
Well, it was a combination of inspiration and luck. I
Hmm.
was inspired to study science, particularly physics, and think about working for NASA for two reasons. One is I was 7 years old when Neil Armstrong walked on the moon. And I
Hmm.
very vividly remember my parents waking me up, getting me out of bed because it was late at night. It was like 11 p.m. and watching him walk on the moon. My sister was really big into it. She had a scrapbook with all the newspaper clippings. And so she got me excited. And then I discovered science fiction and I started reading science fiction novels when I was in elementary school. And those were inspirational. The human possibilities in space and the things we might be able to do got me interested in engineering and science. And I decided I wanted to be a scientist. So I studied physics, got advanced degrees, got a job working for NASA here in Huntsville, began working on space systems, not necessarily propulsion, and then got an opportunity to work on advanced propulsion that was not rocket based. It was something called a
Hmm.
tether.
Hmm.
And a space tether is a way to move around in Earth orbit without using any fuel. And the way I describe it to people is you deploy a long wire and put a current through it. And what that does is it generates a magnetic field. And if when you were a kid, you probably had bar magnets. And if you put two
Yeah,
north poles together, what happens?
they
They
repel each
repel,
other.
right? So the Earth's a big bar magnet. So if you
Hmm.
can fly a magnet in Earth orbit, you can push against that magnetic field. And what that lets you do is move around in space without fuel. So I started working on that. I actually had a flight experiment that was funded. It was part of a Japanese experiment that flew. And that gave me an entree into working advanced propulsion. And from there, it was just a small step and an opportunity I had at work where I raised my hand and said, I'll do it, that led me to working on solar sails, tethers, actually nuclear propulsion, some in electric propulsion, and things like that. So
Hmm.
it was a combination of desire and opportunity, and I was truly blessed.
Well, that sounds great. It's like in- intertwining of both your personal interest and the circumstances that have allowed this opportunity to emerge. So, could you elaborate on solar sails? Like how do they work in particular?
Sure, I'll be glad to do that. Well, when you think about propulsion on the ground, it was a big step forward when we went from canoes and oars, like the Romans did, right, and the Greeks, to and the Polynesians, I think, when they were settling the Polynesian islands, to
Yeah,
sailing, right? Once you put up that
yeah,
big sail, you can then take advantage of the environment around you to do the work that
exactly.
was done manually, right?
Hmm.
And so now
Yeah.
all of a sudden, instead of doing it all by brute force human power, you've got wind blowing against the sail, which propels your
Hmm.
ship and moves you
Hmm.
across water. So
Yeah.
in space, there's an analogous thing to a sail if you go sailing here on Earth, and that's a solar sail. And the way it works is this. I'm looking at you on screen, and your viewers, it may be looking at us, or if they're in a room
Uh-huh.
listening to the audio version, they're seeing the room around them. But as the light reflects from objects and shines in your eyes or falls on you, it's pushing on you because light's
Hmm.
made of little particles called photons. And each of these photons of light though they have no rest mass, which is strange, it's one of those quantum
Yeah.
mechanical things, they do have momentum. And so when they bounce off of you, just like wind reflecting from a sail on a sailboat, this light is pushing on you. Now, you don't feel it because the Earth's gravitational force is much, much larger than the photon pressure and force. The wind currents in the room here in my home, where I thankfully have air conditioning in this hot summer, is more force than I feel from the light in the room. But if you get away from the Earth's gravity and out of the Earth's atmosphere, and you deploy anything large in space that's reflective, it will be pushed on by sunlight. And it is a measurable push. And it's beautiful because it's constant. As long as the sun is shining, you will continue to accelerate. So a solar sail, imagine a large sheet of aluminum foil, much lighter weight, much more robust, that's attached to a spacecraft. And this sail points toward the sun. And as the light reflects from it, it pushes on it. And you change the angle with which the light reflects to steer. And you can maneuver around in deep space away from the Earth using a solar sail and not require any fuel. And the beautiful thing about it is you keep accelerating as long as you're close to the sun, and you can start achieving speeds that are faster than any rocket can provide.
That's
So it really
mind-boggling.
is an amazing propulsion system. It sure is.
Yeah, yeah. Well, so would that be primarily used in perhaps interstellar travel or more in exploration within our solar system, since the
It,
sun doesn't shine that far?
Well, it would be both. And I had the privilege of co-authoring a book with one of the leading experts in the world, two of the leading experts in the world on solar sails earlier in my career. I was called Solar Sails, a Novel Approach to Interplanetary Travel, and it's still available. And it describes a lot of the missions that are possible with sails. And it's not a textbook, it's written for the average person. But the answer to your question is both. Um, Sails near the sun, where the sunlight is bright, there are a lot of science missions that require spacecraft to go to destinations that you have to hover. And when you're hovering with a rocket or a conventional propulsion system, you're constantly having to thrust to maintain position. Imagine that's like being, at sea and there's a current, and the current would wash you to the North Atlantic, but you don't want to go there. You have to use your sail to stay in the South Atlantic, right? So
Exactly.
you're fighting the current. Well, in space, the currents can be gravity fields, the sun's gravity, the Earth's gravity, the moon's gravity. And if you want to stay and observe different parts of any space around these massive objects, you have to fight that gravity. And a solar sail enables you to thrust all the time and not be swept away by the gravity. So the people who study the sun at NASA, those are called heliophysicists, solar physicists. They want to go to various locations that you have to thrust all the time to observe the sun, and a solar sail is the way that you can do that and be able to do it without having to have massive amounts of fuel, or really not even be able to do because you can't carry enough fuel.
Yeah.
Now, for interstellar travel, which I've also thought a lot about, and I cover in my book, A Traveler's Guide to the Stars, what you do is you take a solar sail and you deploy it really close to the sun, where the sunlight is really, really bright. And with all that extra light falling on the sail, you can accelerate very rapidly to a high speed and then fly out from the sun, continuing to thrust until the sunlight's too dim to provide any thrust. But by then, you're going 2-3 times faster than Voyager. Okay.
It's incredible.
And that would allow you to go to really deep space locations and potentially, if you were going in the right way, pass up Voyager along the way, which would be kind of cool to do. And then if you
That would
want to
be.
really go to deep space faster, as you're exiting the solar system, you put big high power lasers out there, light, doesn't matter if it comes from the sun or a laser, and you continue to accelerate as you leave the solar system and you go faster and faster. So you can use them for both.
I see. So how do you make sure the solar sail is not destroyed in the process, either by a laser beam or by the photons bombarding it?
Well, first off, you have to make sure that it can handle the energy of the light that's falling on it. Current generation sails I'm glad you had the graphene book that comes into play here in just
Mm-hmm.
a minute.
Yeah.
Current generation sails that people are talking about flying for science missions would not fly very close to the sun. And they also wouldn't go to the outer solar system. They're strictly
Mm-hmm.
somewhere between Venus and Mars is their operating range, okay, in terms of
Uh,
distances from the sun. If they go any closer, the radiation and the heat they generate might compromise their structural integrity and they might
mm-hmm.
not survive. So that's where we are today. But materials like graphene, and it's how I got interested in writing the book Graphene, was because I
Mm-hmm.
read a technical paper by my friend and colleague, Dr. Greg Matloff at City Tech in New York, that described how you could use a graphene sail with its extremely strong, extremely robust material. It's the strongest by weight material we've discovered, 300 times stronger by weight than steel,
Mm-hmm.
and can be made in large sheets, although we don't know how to do that yet. Could go very close to the sun and survive for these interstellar sails. And
Wow.
so, in the future, we're not ready to fly graphene sails. The technology's not there yet. But in the future, when we build these big interstellar sails, I suspect they'll have as a substrate, or the subsurface layer of the sail material will be graphene. And
I
that'll
see.
enable us to send these probes out of the solar system.
Mm-hmm. Yeah. Graphene is also like an spectacular material that has been will probably be more massively applied in futuristic technologies, I would assume, due to its special durability in many areas.
It is the closest thing we've got to being a superconductor that doesn't require to be super cold. It's not quite a
Mm-hmm.
superconductor. It still has resistive losses, but it's much more conducting than silver, much better than just about any other conductor we have. The
Mm-hmm.
weight, the structural strength of graphene is amazing. If you were to be in a room and if you could build a large sheet of graphene, one atomic layer thick, which by
Mm-hmm.
the way you wouldn't be able to see with your eyes, it would be so thin. You could put an elephant on it and it wouldn't break. Wow. Okay.
Yeah,
So
that's
this stuff is amazing in terms of its capabilities. It was the people who discovered it and characterized it in 2004 ended up winning a Nobel Prize for their discovery in 2010. So I mean, this was groundbreaking stuff.
yeah,
Really amazing.
that's truly incredible. So why don't we move over to your career as a writer?
Sure.
Um, so when did you begin your writing career in science fiction or just as a writer in general?
Well, I write three different kinds of things. I write technical papers all the time,
Mm-hmm.
and that started really in graduate school. So that would have been when I was in my early 20s, right? And then I discovered when I was a teaching assistant at Vanderbilt in the graduate physics program, I discovered that I had a talent for explaining physics to people who were not physicists.
Mm-hmm.
And the example I give is I had to teach labs and courses. One set of courses was physics for physics majors, and coming into that as a freshman physics student undergraduate, they already knew it all, and they were just
Yeah.
eager to show me how much they knew. Right, so
Mm-hmm.
the class went okay. It wasn't my favorite. Physics for engineers, sorry to stereotype, they were more interested in calculating how many digits they could get the answer to, and
Yeah, that
then they
tends to be
weren't
the
learning
case.
yeah, then they were interested in learning the fundamental physics. But when I taught the arts and science students and I could
Mm-hmm.
explain to them this notion of something called, let's say, give an example of something called torque, which
Mm-hmm.
which means mathematically you can explain why you put a doorknob on the side of the door that's far away from the hinges as opposed to right next to
Yeah.
the hinges.
Mm-hmm.
And the door is easier to open and close, and you can describe that mathematically. I could see the light bulbs go off, right? As the
Yeah.
students who were not normally thinking about math
Mm-hmm.
got it. And so I started getting invited to give talks about science to different groups, science fiction conventions, and different civic groups. And I kept hearing, you ought to write a book, you ought to write a book, you ought to write a book. So I had an opportunity again with my good friend and colleague Greg Matloff in 2007 or so, might have been before that, to write my first popular science book called Living Off the Land in Space. He was an
Mm-hmm.
established popular science writer, and we co-authored that book. That led to the Solar Sail book and some others with Greg and his wife C. Bangs, who was the artist for those. And then around 2010 or 2009, 10, I was at a science fiction convention, and I don't put on Spock ears. I go as me to give these popular science talks. And I was talking to a friend of mine who had his first science fiction novel published. You may have heard of him, Dr. Travis Taylor.
Hmm.
Travis he was the Rocket City Redneck. He's on a show called Secret of Skinwalker Ranch, which is on the History Channel. And he and I were talking about how space exploration is like the most dangerous thing that we humans can ever do. Nature's out to kill you at every turn. And we were describing the fact that we ought to write a book that tells the story of a return to the moon and basically have it be Jack London's The Call of the Wild, which was, nature trying to. Have you read The Call of the Wild?
Yeah, yeah.
So, I mean, in that book, nature's trying to kill the protagonist every day,
Exactly.
right?
Hmm.
And in space, that's the way it is. The least little mistake, and you're dead.
Yeah.
Okay. So we were talking about that, and it turns out his publisher overheard our discussion, and she said, "Send me a proposal." So we
Hmm.
wrote a proposal for a science fiction novel called Back to the Moon. We wrote it. It got a really good review in Analog Science Fiction Magazine, which is kind of the go-to review magazine for science fiction. We ended up writing a sequel together called Onto the Asteroid. And then that led to me writing my own novels, such as Mission to Metheny and the Space-Time War and other things.
Uh,
So it began with a collaboration and ended up with some of my current books.
that's awesome. Yeah, I've found your works quite interesting in the way that they're very um they're very informative in the sense that you can understand a lot of stuff, but they're also very relaxed and not rigid as you would expect from a textbook. And it's almost like you're just listening to stories, you're listening to analogies, but you're also acquiring a massive amount of knowledge. And I would earnestly recommend your books to all my listeners that are tuning in right now. So, how about you as a fiction writer? How would you devise plots? Do you work backwards from the ending, or um
Well, that's interesting. You should ask that. I am a plotter. And
hmm
so what that means is I like to have an idea for a book, figure out where it's going to go and kind of how it's going to end before I ever start writing. And
hmm
I create the characters, but as any fiction writer will tell you, as you create characters, if they're going to be believable, sometimes they take a life of their own and they have a mind of their own. And
yeah.
my plot doesn't necessarily fit as well as I thought as the book
hmm
begins and you start writing, because you might write them into a situation and then you figure a way out and you say, well, my character would never do that. That would be against their
Yeah.
ethics. So I got to find another way. And then your whole plan of where you're taking the book has to be
Uh-huh.
reworked. But the nice thing about being an author is in that universe, you're the supreme deity.
That's
So
true.
if I get to the end of the book and I want to tweak something, I can go back and rewrite something at the beginning to tweak it so that it reverberates through the end of the book, right? To where I
Yeah.
want to have it be.
hmm
Now, there are other writers, and I worked with one, the great Ben Bova, who was one of the writers that inspired me as a youth. A few years ago, he asked me to write a novel with him, and I did. It's called Rescue Mode.
hmm
And the book sold well, and it was about a Mars mission where something goes wrong. And unfortunately, it had the luck of coming out the same year as The Martian by Andy Weir,
hmm
which is an awesome book. And people pay
Yeah.
attention to ours sold well, but didn't sell as well as
hmm
Andy Weir's. Um, so that book went well, but he's what's called a pantser. He
hmm
writes by the seat of his pants. And so for me, that was difficult to get used to. What it meant was I met with him and I said, okay, Ben, how do you want to do this? We need to plot this out. And he said, no, 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 I don't plot the book out. Here's the general scenario, a Mars mission where something goes
Uh-huh.
wrong and they have to survive. Here are the characters. He gave me some character sheets and said,
hmm
let's just see what happens.
One step at a time.
One step at a time.
Oh, wow.
So we did that, and it worked out good. The book got good
hmm
reviews. It was a lot of fun to write, and but it was harder for me because based on my day job and my training, I like to have a plan, you know.
hmm Yeah.
So I'm currently working on with Ben, even though he died. He died during COVID. But this past
Unfortunate.
spring, I was approached by his estate, and they've asked me to finish his last novel.
hmm
And so they gave me how he began it without an outline because he's a pantser. And I'm completing that book right now, which is loads of fun.
hmm
So that's kind of my writing style and process.
That's interesting. How do you discipline yourself to write? Would you write every day or whenever you feel like writing?
It's whenever I can. I have
Hmm.
a pretty demanding day job, and I will go weeks at a time
Yeah.
without writing.
Hmm.
And when that happens, I get behind schedule because publishers have these things called deadlines.
Yeah.
And if you want to get paid, you got to get in by the deadline.
Oh, yeah.
So when I get too far behind, I just basically hole up and write. And we'll take some
Hmm.
weekends, maybe take a day off from work. I also write when I travel for work. I'm in an airplane.
Hmm.
I might read some technical papers or something associated with work, and then I'll get out the laptop and I'll write. Or when I get to the hotel room at night, sometimes I'll write. So I basically I don't have discipline. I have deadlines,
Hmm.
and I write when I can to make sure I can meet that deadline.
Well, that's another. It's like the higher discipline almost. It's a restraint on the physical level, so that you have to do it rather than from the inside. But yeah, no, that's interesting. So you write whenever you can,
I
and
do.
yeah. So out of all the books you've written, do you have a personal favorite, or did they all come to you as if they were your children?
Well, I have two children, and I won't tell you anything about favoritism because I love them both. I like all my books, but I have to say that there are a couple of them I am kind of partial to.
Hmm.
One I'm very partial to was my 2018 novel called Mission to Metheny, and it's a
Hmm.
first contact story. It's the first
Yeah.
contact story I've always wanted to write. The plot line for that book and what happens in that book has been with me as long as I can remember.
Hmm.
Now, the beginnings of the book have their origins in a different setting. I didn't know how I was going to begin it, but the overall concept I had outlined long time ago. So that's really one of my favorite fiction books. If I had to pick a nonfiction book as a favorite, I've written several of those, about five. I would say it's my latest one, A Traveler's Guide to the Stars, which came out from Princeton Press last fall, and is probably going to be my best-selling book. It's being translated
Hmm.
into 6 languages, which is exciting for me. That's a new thing for me. It's going to be in Korean, Japanese, uh, Russian, Chinese, Arabic, and Hebrew.
That's great.
So I'm thrilled that it's sold so
Yeah.
well,
Hmm.
and it's kind of my baby in terms of the nonfiction. The
Hmm.
graphene book would have had that position prior to the release of A Traveler's Guide. So,
Hmm.
and in terms of my fiction, though, I also am very partial to a collaboration. Now, my favorite collaboration is probably not the book with Ben. I had a good time with that and learned a lot from a great writer. But Travis Taylor and I are working on a new trilogy, the first book of which is out, and it's called Saving Proxima. And it is a
Hmm.
first contact story set in a not too distant future. So I would say of my collaborations, that's probably my favorite.
I see. So actually, let's just push back to collaboration. So when you're
Sure.
collaborating with someone, do you guys contribute equally to the book, or is there like a difference in um well, it's really not as quantitative as people might think it is, but
Well, it is. My collaborations, with the exception of the one with Ben, have been with the understanding that we're going to do each our own share, half and half. And the way it works with Travis typically is he and I. He's also a plotter, by the way, which
hmm
makes it easier. We get
yeah.
together typically at our favorite Mexican restaurant over a few
Hmm.
days, and we plot out the book. And then typically the way it's worked is I start and I'll write roughly the first half of the book according to the
Hmm.
plot. And then Travis takes it, reads it, edits it, changes it, and then writes almost to the end.
Hmm.
And then I take what he's done and read it, edit it, change it, connect it,
Hmm.
and then write the ending. And then we go
Ah.
rewrite each other a couple of times and edit each other until it's one voice,
Hmm.
and then the book is
Yeah.
finished. So
Yeah.
we each do about half and half. We hand it back
Hmm.
and forth. We each liberally edit each other, and so
Hmm.
far we haven't argued, which is great.
That's
And
great. Yeah.
we're on our fourth book together right now that we're
Hmm.
working on. 4 out of 5. There'll be 5 total when we're finished. Um, Now, my collaboration with Ben was a little different. I did most of that book. He's the senior writer. He
Hmm.
had the idea. He was the editor. He could overrule me on anything, but I probably wrote 65, 70% of that book.
I see.
and then Ben would come in and edit it, change it, make it much better,
Hmm.
because he's a really good writer, right? And the product would be then end up being probably 60-65% me and the rest him, but with his fingerprint on the whole thing.
I see. So, as you've written a lot of, and as you've written and read a lot of science fiction, what do you think is the purpose of science fiction? I know like some authors like Isaac Asimov and Douglas Adams write their books like fables, attempting to convey something about human nature or just have some good irony jokes. Um, like others like Jules Verne dream big about the future. So, what's your take on sci-fi?
Wow, that's a good question. Well, first and foremost, I want to be motivated to turn the page, which means on science fiction, regardless of what its message might be or to the purpose for which it's written, whether it's just the writer wanting to get paid or whether they have some deep social impact message they want to convey, I want to be engaged and want to read it. So I think when I write, no matter what I'm writing, I want to tell an engaging story with believable characters. So that said, I think the purpose of science fiction, it can be any number of things. For me, I try to inspire people. I mean, I may have
Hmm.
things happen where people die. I'm not as bad as some writers. I haven't killed off 90% of Earth yet in any of my books.
Hmm.
But they tend to have risk, and they're good guys and bad people, and things happen. Some characters don't make it. But what I want to do is I want to inspire and entertain at the same time. You will not find me writing a book that has a dystopic ending.
Hmm.
There might be some pretty terrible things that happen along the way, but I want to show that the human spirit and ingenuity can overcome these challenges and we can make tomorrow better than today. And I think
Hmm.
if I could get preachy for a minute, I'm looking at the screen and I
Please,
would say
please.
your generation needs that.
Yeah,
Okay.
I'm
Um,
aware of that. Yeah,
yeah, because this is a much too pessimistic generation. And I understand the challenges that you're facing, but you can meet them head on and you can make tomorrow better.
yeah. I'm an optimist myself, and I can see that a lot in our current generation where people tend to become isolated islands and not really, and apparently just stop, thinking about the future as a whole because you're too traumatized by whatever is going on in the immediate present. But I think people should always be thinking about the future because, um, without that, we wouldn't have been where we are today.
You're exactly right. And the future is not going to be better unless the people of today make it better. And
Exactly.
so I don't like to see people give up. That just frustrates me to no end. Um, I have to. I look back at my parents' generation for inspiration. My both of my parents were born before the Great Depression, so the
Hmm.
early part of the 20th century. They spent their childhood and teenage years living through the greatest economic
Oh
upheaval in
yeah.
American history, the Depression. Then World War II began. My dad was in the Army Air Corps. He fought in North Africa and the Italy campaign. They overthrew totalitarianism.
Hmm.
The Cold War. They
Yeah.
set the policies to get us through the Cold War, where the communism was ultimately defeated with the fall of the Soviet Union. And I look at the challenges they faced, and they overcame them. They did what they had to do. And I look
Exactly.
at my generation and yours, and I see the challenges, and we can do the same.
I trust in that as well. I'm a firm believer of the human mind and of humanity. I believe that our species is there's a deep purpose within us to improve on what we have and um, work towards the elevation of the world surrounding us and to us as a people. So we've been talking about life, right? And what's interesting about life is that it's there's almost a calling, I would say, for each and every one of us to attempt to preserve life. And do you think going interstellar, do you think that's a necessary step in life preservation?
I do. I actually have a whole chapter on this in my book, Traveler's Guide. My first off, I have to be real clear. I have a theistic worldview, a Christian worldview.
Mm-hmm.
And so I believe there's something more than us, right? That
Mm-hmm.
that is a motivator. But even within that context, if you look at the solar system beyond Earth and you look at the worlds of our solar system, and as we
Mm-hmm.
have these exoplanets and we look at these exoplanets and learn more about them, what's quickly realizable, and this goes back to my notion of space is out to kill you, is that there are very, very few places where life as we know it can exist.
Mm-hmm.
The Earth is one of them. And we need to do everything we can to protect, preserve it, keep it as a place for life. But we also need to be thinking about how we can take life beyond the Earth. And as I look at the moon and the asteroids, they are dead worlds. They
Yes.
will always be dead worlds. Life will not exist there unless we take it there.
Mm-hmm.
And so I think life is inherently good, and it's a moral thing to try to preserve life all the way from the bumblebee and the hummingbird up to humans.
Mm-hmm.
And we ought to be expanding to take life beyond Earth and into the universe because it's a good thing to bring life where there is no life. I
Mm-hmm.
think that's a moral good. And in the process, if we can use space technology to elevate people of Earth and help solve problems of climate and energy here, we're not abandoning the planet. We're making the Earth a better place while we spread life elsewhere. That's the way it ought to be done.
Exactly. And I think there's a common misconception that the people that want to go to space don't care about Earth.
Oh,
And
that's wrong.
oh
Oh,
yeah,
yeah, yeah.
no.
Yeah,
Um,
go ahead. I'm sorry.
oh no. And in fact, I was just going to say so many technologies that we have that we enjoy today have been attributed to a pioneerings in the space industry. If you think about like a lot of medicine, a lot of the machinery that we have today are developed by space engineers.
Well, and I think in the near term, I've been giving this a lot of thought, we can use space to help solve the energy and environment problems here on the planet. I mean, we already use it to monitor the pulse of the planet.
Mm-hmm.
When you hear a weather forecast, like right now, there's a big hurricane brewing in the Gulf of Mexico. They're trying
Yeah.
to, or in the Atlantic, they're hoping it doesn't go into the Gulf, but in the Atlantic,
Mm-hmm.
it's a Cat 5. Where's it going to go? Who's in danger of being hit by it? That will be determined in large part by satellite data.
Exactly.
The weather forecast, wherever your listeners are, is informed by satellite data. Your
Mm-hmm.
navigation as you go across town using GPS on your phone, satellite data. Monitoring climate change, spread of deserts, rainfall amounts, global temperatures, sea level, ice pack density, where all of that's measured from space,
Exactly.
right? So that's all part of our life today. In fact, I would contend you can't get through the day without touching space in some way in your daily life. It's just not possible. And I think in the near future, we can go to space with power beamed down from space to help provide green energy for the planet. I think eventually we'll be mining asteroids instead of mining Africa,
Mm-hmm.
the raw materials of our
Yeah, yeah.
civilization, which is a huge step forward to preserving the planet. And I think we'll ultimately perhaps be thinking about putting things called sunshades out at L1
Mm-hmm.
while we get our carbon emissions under control to maybe help keep the planet from getting so hot while we
Mm-hmm.
wean ourselves from carbon. So these are all things we can do in space that have nothing to do with leaving the Earth and have everything to do with improving the quality of life on Earth. And oh, by the way, while we're doing that, we're developing the capability to spread life throughout the universe.
Exactly.
So
So
my answer is let's get busy.
yeah,
Why are we
it's
just
a
talking
win-win
about it? Let's do
situation.
this thing,
Mm-hmm.
Anyway,
Yeah, yeah. Yeah, totally. People, well, all of us should be more aware of, um, as we become more aware of our world and our greater world, the universe, I would say it's the purpose that we have is to improve what we've got, and going space is crucial to this step.
I agree with that. And it meshes with I think it meshes with this whole love your neighbor thing
Mm-hmm.
because our purpose ought to be helping to improve quality of life for our neighbors. And I would define our neighbors as being everybody on the planet, both human and non-human.
Yeah.
And, currently we're not doing a whole lot for the non-human part, and we need to start helping out there. But that doesn't mean we have to sacrifice our technological civilization. We can use that technology to that end. And I just think we need to get on with it.
Exactly. Um, One thing we've talked about, or one thing we briefly mentioned is asteroid mining. And I think
Yes.
the commercialization of space is another interesting field. We talked about in the beginning of private corporations um, getting into the astronomical field. But do you think, uh, or how would you evaluate the potential of space commercialization?
I think in large part it's already there to a degree. I was mentioning some of these data products measuring sea ice and water and
Yeah,
navigational services and all that. A lot of those people pay money to have. Communications is already industrial commercialized in that these big comsats, which are orbiting the Earth and relaying data all around the globe, they're being paid to do that. Big
yeah,
banks use satellites to transfer money. They pay for that service, right? So there is a lot of commercialization. The sense that you're probably thinking of is when can you go? um, and like everything else, I think at first it's going to be the rich. When
yes.
airplanes began flying and airline service was offered, it wasn't people like you and me that got to fly the airplanes in the 1930s across the country. It was the people who had the
Hmm.
money to pay for it that got to do it, right? So I
Yeah.
think with spaceflight, it's going to start out being the billionaires providing rides to millionaires.
Hmm.
But as there are more and more flights, the cost is going to come down. And suddenly you're not going to have to be a millionaire to go to space. You're going to
Hmm.
just be your average, middle class person that gets to do that. And I think that is for your generation. I think you'll see that. I was hoping to see it, but I don't think I'll see that inexpensive an access. I think we'll
Hmm.
see hotels in orbit. It'll start out as where you go on your honeymoon, then it'll be where you
Yeah.
go on your vacation,
Hmm.
right? I think as
Then
we
people might
return to
live there.
and people might live there to support the industries that are developed. So I think
Yeah.
it's coming. It's not coming as fast as we wanted, but it's coming.
Hmm. Yeah. And I'm glad to see that day coming. I would be personally thrilled to take an elevator, or maybe not an elevator, but a spaceship to say to Venus or to Mars. Maybe not so much Venus, because Venus has a more serious issue of high temperatures, and maybe that's not as habitable, but definitely to our surroundings, to orbiting space stations, to the moon.
I mean, I would, if it were affordable and safe and routine, I would sign up in a heartbeat to take a 2 week lunar vacation. I think
Yeah,
it'd be
yeah.
awesome. You know,
Hmm.
I don't know that I would sign up for a 3 year Mars trip. That's a long time.
Hmm.
That's a
Yeah,
long time.
it
We
takes,
need better propulsion. That's what I was working on in my day job. How do we get this trip time down so that could become affordable and doable as well?
yeah. So maybe let's go back to propulsion now that we're talking about it. Do you think we would eventually gravitate away from the current chemical rockets we're deploying, or would there still be a general demand of chemistry?
Well, it's an interesting question because here on Earth, our gravity well, the force of gravity is pretty strong.
Hmm.
And rockets are one of the only types of propulsion we know of currently where you can get more thrust from the rocket than the force created by the weight of the rocket. It's called thrust to
Hmm.
weight. And in order for a rocket to get off the launch pad, it's got to have its rocket engines put out more thrust force than the gravitational
Hmm.
force holding it down. And that's why they lift off and go to space. Unfortunately, if our planet were just a little bit heavier, like if it were 50% larger,
Hmm.
then rockets would not be able to get us to space because they wouldn't have enough thrust to overcome the weight of the rocket. So I look out at some of these exoplanets being found where they are super Earths and they're twice the size of the Earth. And I think, wow, those people will never
Hmm.
go to space
Yeah.
because they won't be able to build rockets to get off the planet. And there are
Yeah.
very few other propulsion systems that give you the thrust to weight. Now, when you get out into space, that doesn't count as much. You want
Hmm.
efficiency for thrust. That's why things like electric propulsion, nuclear propulsion, and those things are really attractive.
Hmm.
But here on to get off the ground, there's really nothing better than an elevator, which you talked about for getting off the ground.
Yeah.
And even if we wanted to build a space elevator, we would have to be able to have rockets to go up to help build it from the top down,
Mm-hmm.
because these
Yeah.
space elevators have a small asteroid as a counterweight attached to the top, and you got to maneuver all that around.
That's true.
So we're going to be using rockets to get up there for a while as we try to reach back down and
Mm-hmm.
build something like a space elevator.
Yeah. Or maybe I guess we could have hybrid propulsion in the future. Like maybe you use rocketry to get out of the planet and then you switch over to some other mechanism that helps you navigate space in
Oh,
general.
that's what we do now. That's what the solar sail would do. It would launch from a rocket,
Mm-hmm.
and the
Oh,
rocket would
okay.
fall back to Earth, and the solar sail would
Uh-huh.
take it around the solar system. There are also electric propulsion systems which use
Mm-hmm.
ions for propulsion, charged particles.
Mm-hmm.
They are very efficient. They're still rockets, and you need fuel. They're about 10 times more efficient than chemical, but they're still a rocket and require fuel. They're also pretty widely in use. There are several missions flying that use that. Um, and nuclear propulsion is coming, where
Mm-hmm.
you use the energy from nuclear fission to heat your propellant instead of burning it
Mm-hmm.
in a chemical system. Now that produces really good thrust performance, but you wouldn't do it to get off the ground because of the risks
Yeah.
of the nuclear reactor. You'd use that in space also.
Yeah. So why do we use nuclear fission instead of perhaps nuclear fusion? Well, that isn't really controllable yet, but maybe in several decades it will be. And would fission rockets be, or would fusion rockets be better than in that sense if
Oh, you've
they
already
were
answered the
controllable?
question. Absolutely. That's why we're not using
Okay.
them today. We can't. We don't have
All right.
compact fusion reactors that put out more energy than that takes to use them. As
Mm-hmm.
soon as we have that reliably done at large scale, then we can make them more compact, and eventually they ought to be possible to be small enough to be on a spacecraft. And then you're really talking. Once you
Mm-hmm.
have fusion drive, you can probably talk about going to the nearest star in a human lifetime, or a
Wow.
little bit longer than that. Still too long,
Mm-hmm.
but doable, right?
Yeah.
So, that's going to be a big deal when we finally get fusion drive.
Mm-hmm. So a fusion drive is basically a fusion reactor within a ship.
Yes. And the propellant would probably be hydrogen.
Mm-hmm.
And you'd superheat it using the energy from the fusion reaction to make it
Mm-hmm.
go really fast as an exhaust. There are also ideas for fusion rockets where you would expel part of the fusion reaction mass
Mm-hmm.
uh, that would be thrown out the back to help give
Uh-huh.
you that exhaust. So there are lots of different ideas about how you might do fusion.
Yeah. Mm-hmm. I heard another idea is where you drop off a bunch of nukes and that blows you forward. It's a terrible way, but uh, is that even a feasible idea?
It is. It was pioneered in the 1950s and 60s by Dr. Freeman Dyson, among
Mm-hmm.
others, and it was a project called Orion.
Mm-hmm.
And what the thought was, and that you have to put yourself back in the early days of the Cold War, and
Mm-hmm.
this is before my time, but I've talked to people who worked it. I talked to Dr. Freeman Dyson about this, as a matter of fact. They believed that we might fight wars in orbit, and that we
Mm-hmm.
would have spacecraft that would have to maneuver with people on board quickly from place to place in orbit to fight the Soviet Union. And so they
Mm-hmm.
wanted to develop a system that could rapidly launch from the Earth, get to space, and fight wars in low Earth orbit. So they came up with Project Orion. And the idea is exactly what you said. This is an oversimplification.
Mm-hmm.
Take a submarine, which is sealed for, in the ocean,
Yeah.
sit it vertically, put a big shock absorber between it and a big steel plate that's the thickness of your house,
Mm-hmm.
and start detonating nuclear weapons under that plate. Boom, boom,
Yikes.
boom. Okay,
Uh-huh.
the impulse imparted by the explosion starts propelling you, and if you explode a nuclear weapon expelled out the bottom every 3 seconds, boom, boom,
Boom.
boom, you
Mm-hmm.
can get to space. And then they looked at what happens if you keep accelerating, and they
Mm-hmm.
found that they could achieve a few percent the speed of light before leaving the solar
Wow.
system. So they actually invented the first, probably technically viable interstellar propulsion system
Mm-hmm.
before, as they were thinking about how they'd fight a war in orbit. But you're right. I don't ever want to do it because that would be really bad for those of us here on the planet. I think
Exactly.
what you'd want to do is you'd want to launch that into space before you started doing that. And I would not want to be on the first crew. I
Yeah.
think I'd wait till it had been proven out a few times.
Yeah.
But Project Orion, it's a great idea. There are some YouTube videos out there where they did non-nuclear testing back in the 60s, and you can see how that worked out. And then there might be some interviews with Dr. Dyson where he talks about his work on Project
Interesting.
Orion. Yeah,
Is Dr. Dyson um the inventor, or rather the conceiver of the Dyson sphere?
it is.
Uh,
He's this very, very
mhm.
one and the same brilliant man. I got to meet him. Wow, this is about 10 years ago at a meeting at Caltech in
Mhm.
Pasadena. And he was the eminent speaker, and I was there for a workshop, and he was participating, but was the inspirational speaker. Getting kind of older at the time. He's since
Mhm.
passed, but he gave a talk about advanced space travel and propulsion and Dyson spheres and Project Orion and all that were topics for the time he was there. Really creative guy.
Yeah. Those concepts are fascinating and quite mind-boggling, really.
I agree.
Um, so would you or do you think that humans would set foot on a planet, perhaps in the in the habitable zone of some stars in the next 1 or 200 years?
200 to 300.
Well,
Yeah,
yeah, because it probably takes like.
it'll take a while to get there,
Mhm.
and right now we just don't have the capability to go. I
Yeah.
think that for sure within the next 100, I shouldn't say for sure, in all likelihood,
Hmm.
around 100 years from now, give or take, we'll send our first robotic probe to another star.
Hmm. It's probably
Human,
the Centauri
hu-
system.
probably Proxima or Alpha Centauri.
Hmm.
Um, Humans are a lot harder. It takes a lot more resources.
That's
The ship has
true.
to be a lot heavier. So I
Yeah.
think the first step, like all of our space exploration, will be
Hmm.
with robots. Before we sent people to Earth orbit, we sent robots. Before we sent people to the moon, we sent robots.
Yeah.
Before we send people to Mars, we're sending robots. And I
Hmm.
think it'll be the same for the planets around the Centauri system. We'll send the robots, then we'll send the people.
Hmm. I've always found Centauri a very interesting system. How they have 3 stars in one solar circle, and or just imagine like if one day be able to set foot on maybe like a planet in the habitable zone of Proxima Centauri. Then at night you just look up, then boom, there's 3 stars. That would be
Wouldn't
pretty
it be
interesting.
awesome? It would be real
Yeah.
interesting.
It's sort of like Tatooine in Star Wars, where you have the binary system.
I'm all in.
Yeah.
We just have to figure out how to do it, but I'm afraid
Hmm.
I won't see it. But it would be awesome. I agree with you. I've
Hmm.
dreamed of that since I was a young person. I think it would just be great.
Yeah. I think the other issue is the amount of time it takes, and time is the ultimate resource. Um, it is sad that perhaps many many scientific advancements would take place after all of our lifetime. And to some extent, it's a pain to see that, because you would hope to experience it immediately, because thinking about it is totally different than actually interacting with it.
Well, here's the optimist view of that. How
Hmm.
I've come to grips with what I would call fear of missing out on the future, FOMO, right?
Uh-huh.
FOMO F, fear of missing out on the future. You don't remember Newton discovering gravity and
That's
how to
true.
quantify gravity. We were not around. I was not around when I just went to see Oppenheimer, the movie,
Hmm.
when all those great physicists were learning the secrets of how to unlock the energy of the atom. I wasn't there. I didn't see it happen.
Yeah.
By the time I was born, general relativity was already known. I didn't get to see that discovery and be a part of how it unlocked secrets of the universe. So I kind of look at the future the same way. I'd like to see
Hmm.
it, but it's probably just the same as what I've already missed that happened back there, right?
Hmm.
So it's best not to look back, and it's best not to have that FOMO. What's really best
Hmm.
goes back to what we talked about: is make it happen sooner.
Exactly. Yeah. But it would also be nice if we could live longer. And um, well, people have been talking about that. And it's common in sci-fi where
It is.
people living thousands of years, like what they did in the early biblical times.
Well, I
Um,
think the 20th century was the century of physics, right?
mhm,
Relativity, unlocking quantum mechanics, going to the moon. This is the century of biology. CRISPR,
mhm,
mRNA technology for vaccines, correcting birth defects genetically before they're born, taking a genetic test to find out if you have a predisposition for a certain disease, and then maybe doing something to head off getting the disease. So we're going to see, I think, um, the age of curing diseases and solving genetic problems just before they happen. This
mhm.
is the century of biology, and we will see revolutionary things happening of comparable scale to what we saw with physics in the 20th century. It's going to be amazing.
I'm thrilled to hear about that and to experience that eventually. I would say so. Growing up, I've always heard my dad say that the 21st century is the century of biology. Um, I mean, I haven't been really intrigued so much so by biology. Sorry to those who love biology, but I've always thought that eventually we'll be able because or I've always thought that biology would be the key to sustaining life. And well, because we assume biological life forms, and I don't think that's going to change. I don't think we are going to become transhumanists and morph into robots.
I hope
Um,
not.
yeah.
I think there are
Well,
pluses and minuses, but the minuses look like they outweigh the pluses to me.
mhm.
But keep going.
But then,
Yeah.
well, there's also a philosophical dispute to that, but we're not going to go into that field. But what I'm saying is, biology is of immaculate significance, and the sooner we realize that, the better, because it's everywhere. We are manifestations of biology. We are subjects of the subject.
I'm getting increasingly aware of that as time goes on.
Yeah.
So you're right. I'm all in. Let's figure out this aging thing. Let's figure out how to cure chronic diseases,
Yeah.
and let's use it to improve the quality of life for people. That's one
Mhm.
of those things I don't want to see just available to the rich. I think if
Yes.
we make these breakthroughs in biology, unlike a space hotel, where I don't really begrudge people wealthy
Hmm.
enough to do it, doing it when I can't.
Hmm.
I think if we get life extension or disease cures, we need to find a way to make sure that it's available to everybody because everyone needs to benefit from that.
Agreed. Agreed. Other people would say, though, that our century is also the century of information and computation, given the rapid developments in computer science
Correct.
and
I agree
information
with you.
technology.
Yep. I think it could be both.
Hmm.
Yep. I
Yeah.
agree.
And both of these fields are significant to contributing to the space industry.
Absolutely. Just a quick thought.
Hmm.
People talk to me about, in fact, I heard a talk not too long ago at a meeting of what's called the Interstellar Research Group. And
Hmm.
this is an organization, it's a nonprofit I helped found. You can find out about it at irg.space. But it's a group
Hmm.
of visionaries who think about how we might go to the stars someday. And we have a meeting every 2 years. And our last meeting was this summer in Canada, in Montreal at McGill University. Lots of students took part,
Hmm.
which was great. And there was a speaker there, Dr. John Bradford, who was talking about the latest research into cryogenic sleep, torpor. How do you, this whole notion of, putting people to sleep for these long voyages through space. And
Hmm.
it's great if we can do that. I think it'd be great to cut down on the boredom of the trip, et cetera, et cetera. The drawback is you still age.
Oh, well, that's
Okay,
not
so
good.
no, it's not good. So if you have a 3 year trip,
Yeah.
you might
Uh,
not get bored, but you wake up 3 years older than when you left, right?
yeah.
It's not going to be. I'll just give an example. One of my favorite space movies, I won't call it science fiction, was
Hmm.
Passengers. Did you see Passengers?
No.
It was out a
Um,
few years ago. It was about an interstellar voyage to another planet, but it was a love story.
hmm.
And these people, they get on the ship, and all the men are 25 and soccer players and look real buff, and all the women are supermodels, and
Hmm.
they go to sleep. Perfect human specimens, right? By the ideal. None of us look like that,
Yeah.
but that's what the ideal was.
Hmm.
And somebody wakes up early. mid-flight and they can't go back to sleep, and they're alone on this ship. So there's an ethical decision. Do I remain awake and die alone, or do I wake somebody up and have a companion? I won't give it away, but I did say it was a love story. So kind of gives it away what happened.
There's probably another person then.
Yeah, but in the story, the flaw scientifically is not the space drive. They did a great job depicting that and the risks of things that can happen on a voyage like that with micrometeorites, dust, getting hit by stuff. The flaw was these people went to sleep for 100 years. And when they wake up, your 25-year-old, really buff soccer player wakes up, he's got a 5 o'clock shadow. That's it. He hadn't aged, right? He's the same age as when he left. But that would be two problems you have to solve: how to get people to sleep for 100 years, and how do you turn off aging while they're sleeping? And I think that's going to be the harder challenge.
Yeah, well, could you turn off all of their cells? Like you just freeze them completely?
I doubt it. That's not turned out well for those who've tried. I think people have tried that. I think Walt Disney has his head frozen somewhere.
Yeah.
And the notion is he's to be reawakened, when A, there's a cure for a disease that he had, and B, when they can wake him up and make sure all the cells didn't burst from getting frozen. So, good luck with that.
Yeah. Well, I think there's still some benefit to putting people asleep, even if they age, though, because the metabolism rates are probably significantly lower. It's like when animals hibernate. I'd say they still age.
They do.
Yeah.
Yep, but I think they do. Maybe it's a little slower than normal, but it would have to be slowed dramatically to make it a viable way, so that if you want to go to the stars at 10% the speed of light, which is really not easily done at all, it would still take 50 years, 40 to 50 years to get to the nearest star. And I don't want to go to bed at 22 and wake up at 72.
Yeah.
Okay, that would be like, what happened?
Me neither.
This isn't fair. So you'd have to turn off the aging.
Yeah.
You'd have to do that.
But it's also possible that, well, when we eventually take off to new planets and distant systems, that we'll just have to create a world ship, and people will just have to. Well, it's not the astronauts that are going to see the star. It's their great grandchildren.
Absolutely. I think that's entirely possible. There are people looking at that seriously. There have been some great papers written by Dr. Andreas Hein, who is in Luxembourg. And his area of specialty, one of the many he has, is looking at world ships and trying to determine the optimum genetic composition and size and what has to be done on a world ship to survive. So I would encourage people to look into his work. I don't think he's written popular science articles, but he's published several papers on the topic.
Yeah, but whenever I try to imagine, especially not being the pioneers, but being like one of the midterm generations being born on like say a warship, a world ship, I would feel particularly bored and probably like, what's the meaning of my life? Am I just an intermediate product? So
it depends on what you have to do during the voyage, I guess.
Yeah.
You didn't ask to be born where you were today.
No.
And I didn't ask to be born where I was born, or to the parents I was born with, or the life my parents had when I grew up in rural East Kentucky. And I don't know. I think when we put ourselves in that position, we kind of assume we have to give up what we have to do that. Exactly. But I think if people were born into that situation, they might have a different view.
Yeah. Well, play with the cards that you're dealt with, right?
That's exactly right. That's the optimist in me, right? That wherever you are, you can make a meaningful life from it if you're given half a chance.
Exactly. So, final question.
Yes.
What do you think about the universe? When you contemplate, or if you contemplate about the universe, are you astonished by its vastness?
Oh my. The way I calmed down after I got news that my mother passed many years ago was to go outside and look at the cloudless sky with the stars. When I am outside, I feel a spiritual connection. And I've already mentioned I'm a person of faith. So for me, I think it's looking at the vastness of God's creation. But even if I weren't, and I were strictly a naturalist in my worldview, I would look out at the vastness of the universe and just be in awe of that and our place in it, and the fact, and this is an interesting question, the fact that we have the capability to look out at that vastness and understand it, right? So, we have telescopes, we get an idea of how big it is, what the processes are. And even though we may never get that far, we have a pretty good idea of what's going on out there and why and how, just based on our science of what we have here. And so I think two things would happen if all the power went out, except in hospitals and airplanes, so people don't get hurt. And the skies were clear and people went out and looked at the stars and could see the stars, which people in urban areas can't. Two things would happen. First thing that would happen is I think people would become more spiritual, regardless of their faith, of whatever that is. And the second thing would happen was funding for space exploration would go up. And the reason for that is people would be saying, what is out there? Why are we here? Why don't we know more about what's out there? We need to go. So in contemplating the universe, I think, the heavens just really declare just a majesty of everything. And it's always been my fascination, always, ever since I can remember. I was about 8 years old when I first looked through a little rickety telescope and saw the rings of Saturn. I had seen pictures of it in a book. It's not the same as when you look up and the light is coming into your eye and you're seeing it in real time. And when you're looking at those stars, that light's been traveling for thousands of years, some of it, to touch you. So you're touching almost the infinite. And when that happens, to me, it's just a blessed time.
Yeah. Whenever I think about how big the universe is, how we're just one system, and then there are billions of systems within our galaxy, and there are billions of galaxies within our visible universe, and who knows how big the actual universe is. Well, it's just so fascinating.
It is, and
we're both
it's
small
glorious,
but also significant.
Absolutely, the fact that we're here to ask that question, you may feel small physically, but in that vastness, there are probably not many intelligent species capable of doing that, which makes life here all the more precious and all the more important to preserve, protect, and expand into that universe.
Yes. Well, Mr. Johnson, it's been an absolute pleasure to have you on David Talks With. Thank you for sharing your insights on all of the things we talked with, whether it's life, space propulsion, your career as a writer, and your many thoughts on faith. We covered a lot of ground today, from the future of space exploration to the intersection of science and storytelling. And I just want to thank you for sharing all this precious information with all of us.
Well, thanks for having me. It was a pleasure to meet you and have the discussion. And I wish you well on your podcast. Do great things.
Thank you. I'd like to conclude today's episode with a powerful quote by the renowned mathematician David Hilbert. Wir müssen wissen, wir werden wissen, which translates to, we must know, we well know. The sentiment, rooted in relentless pursuit of knowledge, serves as a beacon of hope and determination, especially in challenging times. Let it inspire us to persevere and overcome any obstacles in our path. Together, we can and will triumph. Thank you for tuning in to David Talks With. Wishing you a wonderful day, and I look forward to our next conversation.